Okay. Yes, you can see already. All right. Reminding you of National Day promotion, please share the handphone number and the referral code so that your friend get 25% off. You also get 25% off if they subscribe. Thank you very much. All right, let's start. Okay, now over here, starch is broken down into glucose in the small intestine and then absorbed into the small intestinal walls. Okay, so which one correctly describes how glucose is transported into the bloodstream? All right, so can I get everybody to type your answer into the chat, please? Which one correctly shows how glucose is transported into the bloodstream? Thank you, Kiran. The rest, I have 6 of you. I only have one answer. I hope you had your dinner. If not, you can eat and have lesson at the same time. I really don't mind. Don't go hungry. Okay? So if you need to go toilet, just type in the chat, I'm going toilet. And when you're back, just type, I'm back. Only Kiran has given me the answer. All right, Kiran. Oh, thank you, Anna. Kiran, would you like to try explaining why you think the answer is C? Unmute yourself, please. Thank you. Thank you, Zixuan. I'm not hearing you, Kiran. Are you able to use your mic? Ah, Kiran said not so sure, I guess. No worries. At least I know you guessed the answer. Then you are lucky you guessed correctly. Okay, now the answer is C. How do I get C? Okay, so first of all, in the small intestine, actually in the mouth as well. All right, so starch is digested. Actually, starch is digested in the mouth as well. Okay, so digested into glucose. All right, and then absorbed into through the small intestine. All right, which have the walls. So how glucose is transported into the bloodstream? Okay, so over here, first of all, now you look at the word osmosis. Whenever you see the word osmosis, can you tell me osmosis is talking about movement of, is it movement or what? Can you type in the chat? Osmosis is a word that's reserved for who? Osmosis is movement of what? Is it movement of water or is it movement of solute? So osmosis is the net movement of what? Can y'all type into the chat? Is it movement of water or is it movement of solute? Can you choose? Not sure, just write not sure, don't need to guess. All right, so net movement of water or net movement of solute? Can everybody type in the chat? What is osmosis? Can everybody type in your chat, please, quickly? Just don't guess, not sure, just type not sure. So I'm asking this. So osmosis is net movement of what? Is it net movement of water or is it net movement of solute? Okay, thank you, Chloe. Chloe, at least you put a question mark. I know you're not 100% sure, but at least you tried. Thank you, Chloe. The rest, net movement of what? Okay. Unlike opposite concept. All right, good try, but opposite concept. Kiran, opposite concept. That's when you see Zixuan also opposite concept. Okay, that's where I know y'all don't understand this. So it's very important that y'all give me a response. If not sure, it's okay. Just type not sure. Or like what one of you did. She write down water question mark. Question mark means you're not so sure, but you're making a guess. All right. So osmosis is reserved for water. All right. So that doesn't matter if you get this wrong, but please get it right after today. Osmosis is reserved for water. All right. So the water is moving. Moving from where to where? All right. Moving from a place of later I'll give you the slides, okay? Of water and must through there must be osmosis involve a membrane. What kind of membrane are we talking about? Must have membrane one osmosis. If don't have membrane, it's not osmosis anymore. Osmosis must involve what kind of membrane? Everybody? Yes. Thank you. I hear a nice voice. Yes. Who is talking?
Me.
Thank you. Who is the me? I don't know why my handphone doesn't show the. Let me see. Okay. Who is the me? You talk again so that I can see which window is
Hey.
highlighted. I don't see. What's your name? Is it Zixuan?
No.
Aaron. I can see already. Aaron is talking. Aaron, yes. Through what kind of membrane?
Reverse osmosis.
Louder. Your voice get off again.
Reverse osmosis.
Reverse osmosis is opposite of osmosis, but then I'm talking about membrane. What kind of membrane? Semi what? Permeable. All right, semi-permeable membrane. So osmosis must talk about movement of water. So let me write here, highlight for you. The word osmosis is reserved for water. Water is moving, not solute is moving. All right, osmosis is water moving and must have a semi-permeable membrane. That means the water passes through the semi-permeable membrane. All right, so if you look here, osmosis, they say glucose is transported. That means glucose is moving. Then there's nonsense. Osmosis should be water is transported. Osmosis is reserved for water, not reserved for glucose. All right, therefore, here straight away A is wrong. All right, so glucose is transported is wrong. It has to be water. All right, so water. Okay, so again, osmosis here talk about glucose, straight away is wrong. So straight away A and B are wrong. Okay, then I have diffusion here. I have diffusion here. All right, so diffusion can be for glucose. All right, diffusion can be for anything. Osmosis is reserved for water. So osmosis, I'm going to write here, but please don't write this for exam. Reserve. All right, reserve for water. Okay, exclamation mark. Please remember that. So that's why I know A and B are nonsense is because here glucose is moving, but osmosis is talking about water moving, right? Osmosis is water moving. Okay, then I'm left with C and D. Now glucose is transported into the bloodstream via diffusion from a region, a place of higher concentration to a region of lower concentration. Here is higher to lower concentration. D is lower to higher. So can you type into the chat? Should it be higher to lower or lower to higher? Can everyone type into the chat higher to lower or lower to higher? How is the movement? Type in the chat, is it higher concentration move to lower concentration or the opposite? Lower concentration move to higher concentration. Can you tell me higher to lower or lower to higher? Thank you, Zixuan. Thank you, Chloe. All right, I give you a hint. Think of waterfall. Waterfall should always move from where to where? Water falling down. All right, so waterfall will always go from a higher place to a lower place. Right? You'll never see a waterfall going from low place to high place. All right, unless you have a pump that pumps it up. Okay, therefore the answer is C. All right, so lower to higher is wrong. All right, so it has to be higher to lower. Okay. Right, so osmosis is reserved for water. Now, some of you are quite weak for this topic. I have some slides here. So the difference between diffusion and osmosis. Now, diffusion can be anything. Solute, any solute can be sugar, can be salt, can be anything except water, not water lah. So for example, all right, sugar or salt or other things, etc. Right? Other things. Okay. So it can be anything. And it moved from HL. Remember the HL milk, the brand? So that will help you remember H to L. All right, this is just a memory aid. Okay. Have you watched this video before? Can you tell me this one about? Do you know what is this? That is reddish brown in color. Can you someone type into the chat if you remember what is this reddish brown chemical? Anyone? What is reddish brown chemical? Anyone? No one? Okay, so R and B. So it's BR2, bromine. All right, so this is reddish brown bromine vapor. Okay, so this bromine vapor is moving from a place of higher concentration to a place of lower concentration. So after a while, you will see the bromine moving up. Later, the whole gas jar here will be reddish brown, here will be reddish brown, here will be reddish brown. All right, right now there's no bromine here. So the bromine will diffuse upwards. I use the word diffuse because bromine is not water. Water is meant, water is reserved for osmosis. All right, so diffusion can be anything. Diffusion is movement of any particle, can be sugar particle, can be salt particle, can be bromine particle, can be any particle from a region of higher concentration to a region of lower concentration. All right, can you tell me, have you watched this video? Yes or no? Type into the chat, have you watched this video? Boys and girls, I need response so that I know how to help you. If you all don't respond, you keep quiet, I don't know what to make out of it. Zixuan, have you watched the video? This video, reddish brown bromine. Okay, never mind. Then I'll just show you very quickly. Just a minute. It's now because I got a lot of things overlapping. So let me copy and paste this over.
Every year, 1 million women all over the world suffer from breast cancer.
Share screen, new share. Hey, how come you still don't see it? Let me share, stop share, share screen. All right, then the difference between diffusion and osmosis. All right, so I already told you osmosis is reserved for water. So this osmosis is actually equal to diffusion of water. All right, so diffusion can be of anything. If you are talking about diffusion of water, I give it a special name called osmosis. So osmosis is the net movement of water molecules, the Mickey Mouse water molecules, from a place of higher water concentration, or you can write higher water potential, to a place of lower water potential. And it must involve a semi-permeable membrane. Whereas diffusion got no membrane one. No membrane is needed. All right, so diffusion is net movement of anything. Okay, so okay, hang on. Okay, now some of you talk about reverse osmosis. Now reverse osmosis is actually opposite of osmosis. Okay, so let me write here. So for example, if you have a place, let's say, okay, so this is a membrane with tiny holes. All right, so this is semi-permeable membrane. All right, so let's say you have a lot of water concentration here. So let's say here you have out of 100 water molecules. All right, then you have, let's say, 40 sugar. 40 sugar molecules dissolve in 100 water molecules. Then over the other side, you have 100 water molecules, but you only have, let's say, 20 sugar. Okay. Now, because the water molecules will be attracted to the sugar, so effectively you only have 60 free water. That means 60 water molecules having the freedom. Here, 100 minus 20, you have 80 free water molecules. All right, because what is happening is every sugar molecule that's dissolved in water, it will attract the water molecule. All right, so 40 sugar will, like, they will attract and get to 40 water.